Hello and welcome to SudoKanard. This puzzle is called Ascending Starter Sudoku. It was created by Dutch author Richard Stolk, and it was featured in the recent Netherlands Sudoku Championship, which was a live event for the first time in recent years. For the reasons I let you guess. So the special rule of this is that the number you see in the margin is the sum of the first few digits, and you stop when the sequence stops ascending. For example, you could have a 1, a 4, and an 8, and say a 6. Then this is ascending up until the 8, and it stops ascending here, and the sum here is 13. So that's a special rule, and this variant will appear in the upcoming Sudoku Grand Prix, and it's organized by the Netherlands, and my guess is that Richard also created the puzzles that we'll have in this round. So where do we start? This 3 looks quite suspicious. I think that only 3 goes there. If I try to put several digits in an ascending way, then the next digit will be bigger than 2, so the sum will never be 3. So I think the only way is to do that. And then the next digit must be lower. And something similar is happening here. If we didn't have this, we could have a 1, a 3, and a 2. But you see that this breaks. So this, I think this has to be a 4, and this has to be lower, and thus a 1 or a 2, because 3 is already taken. And this is next, this is opposite this 10. We must have at least 2 digits, and because those digits are already taken on the row, I think the only way is to have 4 and 6, and therefore this has to be lower than 6, and it must be a 5. And there, those are 7, 8, and 9. This must be smaller than 14, so it's 1, 2, or 3. And we must have another digit, another ascending digit here to go to 14. And you see that the minimum value will be 7, and here 1, and that makes 14. So this should be lower. Well, on paper, I wouldn't put such an abundance of pencil marks. I would just draw an inequality sign. This here looks very suspicious. Actually, you see that because 7, 8, and 9 are here, we can't have a sequence of more than 2 ascending digits in here. We couldn't have something 7 and 8, for example, because if we put 7 here, 8 is there. So those must be the sum of only 2 digits. I can't put a 4 here, so this won't be a 9, and this will be 5 or 6. And because this is ascending 7 here, we need an 8 there, and it wouldn't be increasing. And I can't have 7 and 8 because I would have no choice here. So that's a 6, that's a 9, and that's a 5, that's an 8, and that's a 7. So all of these clues on this side are fulfilled now. And this is 2 or 3, where we have 4 choices for those cells. I don't think I can do anything more. Those are from 7, 8, and 9. 5 and 6 are both in here. And, well, this 20 looks interesting. This 38 as well. Because we know the sum of a certain amount of digits is 38, which means knowing that all digits in the column sum to 45, it means that the leftovers must sum to 7. So the only way is to have a 2 here. And that's a 3. And then the other digits are ascending, so we have a big thermometer here, which has to be this way. So this is a massive step. And this is interesting because now we can't have 3 ascending digits here. We would need 1 and 2. That doesn't work. So 13 is just the sum of those 2 digits. It doesn't include a 4. It won't be 6 and 7. So it's a 5 and an 8. And 6 and 7 must be around here. And those are 2 and 9. That's not the 2. We have 3, 4, and 5 here. 1, 2, and 9 there. But those sums can't start with a 9. So 9 is here. And there's something has to be done in here. We see that those 3 digits have a maximum of 13. So we need at least another digit. And it won't be 8, so it will be 7 or 9. But 9 won't work. If I try to put 9, that's 15. I can't make 2 with those 2 digits, so that's a 7. We have 13, we need another 4, so it's a 1 and a 3. That's a 2. So this plus that is already 10. We need another 13. 5 here would need this to be an 8, so that's a 4, that's a 5. We need another 9, and that can only be achieved with a single 9 in here. Now this 7 could be a single 7. It could still be a 1 and a 6. So that's a 1 or a 7. 22 somewhere here. We have 17 here, so that's a total of 39, and there must be a total of 6 outside the 22, and the only way of achieving 6 in the middle is to have a 2-4 pair here, and this is 5, 8, and 9, which is really 22. 1 and 6 is still possible in here. Is there something to be done with the 10? It can't be 4 digits because we would need the 3. It can be 2 digits with the 1 and 9. No, actually 9 here wouldn't work because of this 18. So 1 and 9 is not an option. 2 and 8 is not an option. 3 and 7 is not. 4, 6 would seem to work. That might be a possibility, for example, 3 and 9. So 4, 6 seems to work. With 3 digits, perhaps 1, 2, 7. No, 1, 2, 7 wouldn't work because then we would need a smaller digit here, and that wouldn't happen. 1, 3, 6, 1. I think 4, 6 is the only way. And that was probably not the wisest choice to focus on this part. Maybe there was another clue with the 13 or the 20 that was easier to pass. Well, I'm not sure about that. Anyway, if I try to put 4 digits into the sum, I would need a 7 here, and I've already got a sum bigger than 18. So only 3 digits will go in here, so the remaining 2 digits have a sum of 12 without using 4. It could be 3 and 9. Or 5 and 7. No, but 5 and 7. If I try to put 5 and 7, then the ascending sum is bigger than 18. So the only way is to have 3 and 9 in here. Places a 7 there. And on this row, that's not 9, so that's 8, that's 9. And this is a 3. That's it. This 9 resolves the 2-9 pair. Well, we're getting there. Here I need 5, 6, and 8, so this is 5. Those are... I need a 4 somewhere, so that's a 4, that's a 1, that's a 2, and a 7. And that works for this clue. 2, 3, and 6 here. I need a 1 somewhere in here. That's the place. 2 or 8 here. So maybe there's something on this row. Here I need 1, 2, 7, and 9. So this is 2 or 7. This is 1 or 2. 9 can only go here. And to fulfill this 13, I now need a 4. 20. We know that 4 won't be included in the ascending sum, and we need at least 3 digits, and the biggest 3 digits remaining are 5, 7, and 8, which add up to 20. So they are the correct candidates. All right. What did I do? That's an 8, not a 6. That's a 2. I think, yes, all ascending starters now have been resolved. The rest should be plain Sudoku. So that's a 2, that's a 7, a 5. 5, I said. 7 and 6. Here I need a 3 somewhere. It's here. That's a 6. There's a 4 and a 6 in here. So 4, 6. It resolves this 3, 6 pair. That's 1 and 8. That's 5 and 3. And that's 1 and 2. And that's it. Very nice puzzle. Really not that difficult. It's a really good puzzle to just get acquainted with the variant, I think. And that's typical Ricard. And I think the puzzle in the upcoming Grand Prix will be more difficult because it's worth something like 90 points, so it should be more difficult. But we get a grasp of what logic can be applied, what computations we can use in such a setting. Thanks for watching this video. See you soon on SudoKanard.